Hello, today I will show you how you can run local large language models that you downloaded from LMStudio with your VScode editor. So after you downloaded LMStudio, you will need to download any large language model of your choice. For this, you click on this model search or use hotkey Ctrl up arrow and M, and you will be able to see stuff picks and sort it with your specific filter. Right here we can see very detailed description of each model. We can see its capabilities such as vision, tool use and reasoning, and how much gigabytes we will need to download in order for this model to work. In addition to this, it can tell us whether we are able to load this model completely on our GPU or don't. In my case, I am able to load this model only partially in my GPU memory. So I already downloaded more simple model that I am able to load completely in my GPU memory. For this video we are going to use Nematron 3 Nano 4 billion. In order for us to use this model, we will need to load it first. For this, click on it or choose it from your models window. It will be highlighted. Next, click load on the right side panel. There you can tweak some settings which you can see by default, and click load model. Right here I will explain you how you can tweak your model in order for it to work fast even on small GPUs. Right here you can modify our API identifier that you will see in other apps when accessing this model. For simplicity, I will just call it Nematron. You can see that it's quantized. Above we can see estimated memory usage we need in our GPU for complete offload of this model into VRAM. In order to decrease this amount of gigabytes VRAM, first of all and simplest, we can tweak context settings. For purpose of this video, we are not going to need this amount of context length, so I will just reduce it to, let's say, until model would fit into 4 gigabytes of VRAM. Next we can see how much of our memory we want to offload into VRAM of our GPU. In our case, I'm able to load this model completely because it doesn't have a lot of context, and how much of threads you want to give this model. For me, 4 threads is fine. Next parameter goes evaluation batch size. So this parameter specifies chunks of token that your prompt will be splitted into in order for processing. In my case, 512 input tokens is fine, but you can decrease this amount if your GPU have faster frequency or increase. And next we have max concurrent predictions. This parameter is used primarily in reasoning models, so we aren't really needed. I will decrease it by 1. And unified KV cache is used for storing memory from each concurrent prediction in one place. If we tweak this or if we change this parameter, it won't do anything. Next parameter is rope frequency base. They aren't explaining how this thing works, but they tell you that if you increase this, it may affect your performance in a better way. I will leave it on auto. And same for rope frequency scale on auto. Next thing we can turn on is offloading KV cache to GPU memory or our prediction cache. I will leave it as is. Next we can turn on or off whether we want to keep our model in memory or not. Next parameter is mmap, which improves loading time for the model. Again, they aren't really telling you how this function works, but telling you that if you disable this may improve your performance when the model is larger than available system RAM. I will leave it as is because my model size aren't bigger than my GPU memory. Next parameter is seed. If you want your model each time give predictable results or same answers, you can set fixed seed and model will be answer the same things again. Next parameter is flash attention. It decreases memory usage and generation time on some models. As I understand, this uses some of predefined LLM functions to answer you more quickly. Next parameters I'll leave as is because our model is already quantized and I don't want it to be any less worse or better. You can save your settings for your specific model, and when you tweak your settings you can load your model into memory, which we are going to do. Right here you can see that when your model loads successfully, you will be prompted with this message. After you loaded your model into memory, you should go to the developer settings or use hotkey Ctrl 2 And right here we can see our loaded models, and it's animatron that we just set and tweaked our model. Next thing we need to do is start our server in order for other applications to be able to access our model. At the bottom we can see our developer logs, and it tells us that our server just started. Next thing you may want to tweak is server port by default, whether your server requires authentication. Maybe you want only specific apps to access your model's server, and whether you want to serve this on local network, so as devices will be able to access it. Under each parameter you can see a tooltip, but most of them needed for production or for specific serving on your network, so I will leave them as is. Next you can tweak your model context protocol settings, but we won't do it right now. And right here we can see that our model is reachable at localhost address with 1234 port. So we just loaded our model and we can test it. So for this you can switch to your chat tab in the left side panel or use Ctrl+1 hotkey. After you switch it to chat panel, let's choose our model for testing in our chat window. We already have our animatron loaded. On the right panel you can tweak your settings, set system prompts, enable or disable reasoning, and truncate singing history. Personally, I won't do it or enable any skills for this model. We're just going to test whether this model works as expected or not. So, as you can see, our model works fine and fast for simple tasks. Next question: how you can use this model in VS Code for code competitions and agentic tasks? For this, we are going to switch to our VS Code window, and first thing we need to do is to install Continue extension for Visual Studio Code. For this, you go to your extensions tab or press hotkey Ctrl+Shift+X and search for Continue. After you searched, you click on the first extension that has verification, you install it, and I already installed it. So after you installed it, on your left panel appears this Continue icon. You click on it. You will be prompted with some onboarding guide. Just click yes or skip everything until you reach this window. Next thing we need to do is to connect our local config. Don't forget to turn off anonymous telemetry if you want. When you set up your local config, you will need to add chat model. So when you click add chat model in your chat window, you will be prompted to add chat model. First of all, choose provider for your model as LMStudio, and everything else leave on after detect. As we can see, our model already automatically loaded and it shows us our config YAML. After this, we can ask to make any changes to our file. For example, I asked it to write basic comments for this basic hello world script. When we switch to our LMStudio, into developer tab, we will be able to see our prompt processing percentage. In the bottom panel, we can see when our prompt is completely processed and all logs from our model. Right here we can see that our prompt processed and our model finished streaming response. We are being prompted to read currently open file. I accept and allow this to read our currently open file. As you can see, it read our file contents and now suggesting some basic comments. Keep in mind that my model is very simple and has very small context window. That's why I ask for so simple task on so simple scripts. Later I will show you how you can use customly tweaked local model or remote model with API keys for more complex tasks. In addition to prompt processing percentage, we are able to see how much token our model already generated. As you can see, our model gone completely insane and suggests C++ style comments for our Python script, so I guess we need a little bit more powerful hardware to run more sane models. That's it for this video. Bye.